Chip, I've recorded to the cloud, so when I pass this off to you and I get on my way, it's gonna be continuous.
Okay.
Well, we all know where we are. As far as topics I'm aware of today, I think Chip is going to show some of the new P2 Edge oscillator improvements.
Nice.
Getting his hardware set up. And while he does that, I thought maybe we could answer a question that came in from a customer in Germany who wanted to stay up and join us today, but maybe he's here. And I thought I would put it up here, allow us to read it, and then just have the community answer it. I'll take an answer at the first part of it. So give that a read for a moment. So let's take this one in pieces then. And who would like to answer the first part of it? What do you view as the official supported Parallax language and tool system? Someone give it a shot.
Yeah, this is Mike. It's really spin and assembly.
Running
It
on,
also supports C. They didn't mention that.
okay, spin, assembly, and C, and running on which platforms?
Yeah, well, if you use Eric stuff, you have basic C and spin.
Yeah, I think
I actually played around a little bit with that basic he built in his suit there, and it's a really nice basic. I mean, it supports even line numbers if you want to.
And then we can point out that you can also mix these languages up if you desire.
Yes, yeah, you can basically make an object, use spin objects in basic and C, and you can use C objects in basic and spin, and that's kind of cross. You can make objects in each language and combine them and use them from the other ones. Eric did a really nice job there, and now Würfel, Ada put a bytecode interpreter in there for the P1, at least they have one now. There's the original ROM bytecode interpreter, so you can program C to assembler, which is pretty fast, or program C to spin bytecode.
now one of the things I've been working with too. What he does say here is, assuming it's a he, continuously developed by Parallax. I've been pushing the edges of, not all of the edges, but some edges of the PASM and the Spin 2. And as I find things, I use Peanut and Prop Tool, and then I push them off to Eric if I find anything that FlexSpin is not doing. So Eric's been very responsive in terms of making sure that anything I find is eventually taken care of in a new release. So while I would officially say Prop Tool and Peanut, Peanut not being exposed externally, I suppose, are the core, and therefore Spin 2 and PASM 2 are the core languages. Eric's been doing really well, so these other languages will perform well on the processor.
Okay, so the official platform really is Spin 2 and PASM running on the Windows Propeller tool, but Eric has made a compiler which we try to maintain compatibility with, and you often test it with your work, and I try to run the quick bytes in it, and that compiler is used in the VSC examples and in FlexDrop and runs on all operating systems, right?
Yes. Yeah, that sounds like a fair way to say it. And Eric's been, and kudos to Eric, because he's been doing a lot of work. While it's not his main focus, he's been doing a lot of work to really address anything we find.
And so give him some money on Patreon and say thank you to him, because we need to keep him motivated, which he is.
Absolutely.
Okay, so for those of you familiar with other microcontrollers or maybe other multi-core microcontrollers, how do you distinguish the P2 from those other chips? I know this is a 50,000 forum post, perhaps. How would you summarize the
And
difference?
the question is rhetorical in this environment, but for someone watching this video, it could be informational.
Yeah, I think there's that one document which Chip once wrote where he described why he basically built the 2P1 at that time. It's kind of, I don't know where it is, Publishing might know. It's one of the oldest documents of the P1, basically describing the philosophy behind the whole thing and why the Chip decided to go another way than other controller did. I think that is a very nice document to get kind of the, basically you have to get hold on Chip's thinking to understand how to program the P1 and P2. It's different from normal setups and normal microcontrollers because of the different idea behind, and that is what distinguishes the P1 and P2 from everybody else. Sure, you have 4-core ARM chips, but you have to run a Linux on it. You can't really as easy as you can with a P1 or P2 parallelize things, and that is, in my opinion, the main point on the P1, P2.
Along those lines, Michael, one of the things unique about Parallax is the design itself was open, was community supported, and the chip designer and implementer is readily accessible, reasonably so, to the community that's involved in supporting it.
Yeah.
And that's different from most other manufacturers.
Yeah, actually, that is also a point we should make. The community in this forum is addictive. I mean, it's addictive. You can have everybody who comes into this forum gets a welcome, and I'm following the forum basically daily if I don't have anything else to do. And I think it's the most helpful forum. I don't have any other which is alike, and I'm watching a couple of them. Even if I don't program COBOL anymore, I'm following GNU COBOL, and but this forum is as helpful as it gets, in my opinion. And you are a big contributor, Mike Green. I mean, what I learned from you with Basic Stamp, it's image. It's a bomb. I mean, you are good. And that and now you are starting with a P2, which I like very much.
And then one final benefit is wir können Deutsch auch sprechen. So if you want to...
Ja, wir können auch Deutsch sprechen, das ist richtig.
Okay. So maybe it would be good to round this up, just a couple more minutes. What do you consider the top strengths of the P2? So you mentioned true parallel processing, the flexible I/O.
And basically that what was called the OBEX, and which is now kind of in limbo, sort of, if you don't want to like it. But in my opinion is that you have those modules to which it's so easy to plug something together just for testing. I don't know, half an hour, and you have something running. I mean, that is what I honestly like on the P1 and P2, that it's so easy to get something, the basics running. You have kind of input, output on the screen, keyboard, pins. It's so easy to plug things together. And you don't need to read hundreds of data sheets, like with and 20 different chips, because one has IC2 and the other has on that pin SB1. It's you have just one P1 and one P2. There's no 20 different versions. Because of that flexibility, you have to soft load peripherals and drivers. That is also, in my opinion, a very main point is that every pin is like the other. You don't makes layout a lot of more easy. For example, you can choose whatever pin is next to your connector.
Okay, that's helpful. So I could also say the kinds of applications that are using the P2 that I'm aware of. In general, they include many analog inputs. One customer is measuring a heck of a lot of things all at once. There's some motor control, sensing, parallel projects of kind of industrial scale. And there are some robotic applications and some flying robot applications. That's where it's being used so far.
I think one of the things that first drew me to the P1, and of course is still true for the P2, is the fact that the cores can literally monitor each other's behaviors without affecting the performance of the other cores. And that's pretty much unheard of. The ability to have very little, to keep the volume of code very low, to do monitoring and to do control is stunning. We can we do multi-core all the time with big OSs, with full Linux and stuff like this, but we have so little volume of code running while we're running on the P2 to accomplish tasks. It's quite wonderful in the sense of trying to understand what the performance is, trying to understand what the behavior is. A lot easier to work with when you're doing direct device control.
Thanks, Stephen. And for the customer who's going to watch the video, feel free to join us. We'd love to have you. Seems you might already be here, and you're welcome. He's in the chat. So if you want to, you can go to bed. Otherwise, stay on and we'll see what's happening with the P2 Edge. So Chip, are you ready, or should we talk about just our production run on the P2 Edge if anyone's interested in that?
Yeah, what do you want to say about that regarding time and volume?
Well, just in general, just describe that we set up the pick and place and we ran some parts, and then we stopped and we sent some boards off to Chip and Jeff and to Michael, and we discovered that the PCBs were not all the way drilled through, so things were not grounded properly, and therefore our RAM chip, or not our RAM, was it the flash? The flash did not work. And so
Yeah, everything else works. We were able to prove all the power supplies and the clocking and all those improvements work, but somehow some data got dropped in the drill file that went out to the PCB guys. So we have these vias that never got drilled, that like never grounded the, you know, the ground on the flash chip, pin 4, and some other signals. So, but we've compensated for that. I mean, we've been able to patch up some of that. But I'm pretty sure the whole design works. It's just, it turns out there's only one PCB per panel that has all the drill holes drilled. And then in the array, as it got stepped and repeated, a bunch of holes got
worse. So, and that was from one of our better printed circuit board suppliers. So as of now, the surface mount
well,
line.
It was our fault. It was our fault.
Oh, it was? Okay.
We didn't give them the data.
Ah, interesting. But you said one of the positions had the data, or seemed to.
Well, it's like this, the data was not stepped and repeated for some of the hole patterns. So they wound up on the corner board at the lower left of the array, but they didn't wind up on the other boards.
Got ya. So anyway, the SMT line is torn down, and we're going to be scrapping some serious dollars. And in 3 to 4 weeks, we'll hopefully have more to talk about. But at that point, probably the P2 motor driver add-on will be in competition for our time on the surface mount line.
Okay, by tearing down the pick and place, you mean that we didn't really tear it down. We just took the reels off the feeders that were for the P2 edge, and now we're setting it up for some other run.
Yep, we've removed feeders and then we've doubled down and gone shopping for more parts in the meantime.
Yeah. All right, well, Ken, you got to take off somewhere, right?
Yeah, you're good to go. I'll hang out for 15 more minutes.
I was going to say one more question. Where is the RAM version of the Edge in time?
He was going to start working on that yesterday, but when we realized there were problems with this current P2 Edge, that took his attention back. But he's got the motor driver board all done. That's off to, be fabricated. And now we've got to make sure that we get this board right and then send it off again to get it refabricated.
And then the RAM base slides in after that. Okay.
Yeah, as soon as he's done, I mean, there's really no design work to do anymore on this P2 Edge. He just has to make sure that he has to do a very careful inspection and make sure that the drill data is everywhere it needs to be.
Yeah, yeah. That's a shame. Nobody likes to have that happen.
Yeah, I don't know why it happened, but something didn't get stepped and repeated. I mean, and it was just the ground vias around the flash chip. There were like 9 of them on 6 different circuits.
Wow.
It's like there is a problem when the system, not the system, but the board design software transformed one board into a panel, or that transformation is done on the supplier.
We did it. We gave them wrong data.
Oh.
Because we panelize the boards and we have these special routing patterns and places for them to like cut a little V so that we can separate the boards easily. And that was all our doing.
And if you analyze the masks don't have the drill holes at the right position. The masks were messed.
Right, these boards are built in a panel array like you see there on Ken's camera. And only the one in the lower right had all the drill holes. The others missed vias.
Can't it be a problem with the software you are using? Perhaps a new version that got a problem due to some difficulty, not to your work, but with the panelizing routines.
Something, yeah. I mean, I think we were talking about it. We were up late last night going over this. And I think Michael had some handle on it, but I don't remember the detail.
Okay.
But it'll get fixed. He'll go, I mean, we'll probably figure out what caused it, and then we'll do a very careful inspection of every instance and make sure it looks right. Ken, what have you got there?
Those are just the panels. Just looking at what we have. We can save these for an event at Parallax and make keychains out of them.
There's a hole for it.
Yeah, we've already got the hole for the keychain.
Yeah, 2 holes.
This can be a very expensive keychain.
Yeah.
That's true.
Yes, you could.
So you have,
Chip, did you say there was a couple of them on the lower corner or something that did have the correct holes?
One, the lower left corner instance had all the holes, the others missed vias.
geez.
So you're gonna get at least one per panel that you can use?
Yeah, so here's 20 of them, right? And this guy would have a heck of a lot of fun dealing with that request.
Oh, really?
Oh, that's Terrell. Yeah, he and David make it happen.
They do not want to deal with that request. Hey, Chip, before you get started, I don't know if Rainier wants to talk about his development tool project. which is interesting
Yeah.
because the P2 development board we're making keeps climbing in cost. There's more of a fit for the lower cost ideas like Lachlan is talking about and, P2D2 originally envisioned.
What is that, Jen?
This is
Yeah,
this
what we're
right
all
here.
about.
This is
Yeah.
the money. This is the CyberBot board. So it's a microbit based robot board, and it has on the back of it a P1 as a coprocessor,
Oh, nice.
so that we can do things the microbit can't do, like have really good timing and interface to more kinds of sensors.
Oh, fun.
So we build tremendous number of these things, up to 1,000 a month.
It pays for P2 adventures.
Rainier, did you want to say anything about your effort you have underway?
Yes, I'm on the way to my holiday.
Oh, excellent.
We can see.
Wait, what?
So I will be out of office for 2 weeks now. In the meantime, I think I will have a little package that is sent from Man at Works. He finished a first set of KISS boards, and he managed now to send some to the US. I think he will send a bunch to Australia, and I will have about 100 the next week. I offered them I made announcement in the forum, and anyone who is interested can send me an email and will be served. So thanks, Ken. You allowed us to make a very good price and to lower the threshold to enter in the P2 adventure.
Most welcome.
So,
Okay, so for those who don't know, what he's speaking about is, Rainier, you didn't formally say what you're doing, but I don't know if you want to mention you're restarting P2D2, right?
no, not yet.
Okay.
I didn't talk to Peter over the last few months. Since he vanished from the forum, I was not in contact. I tried to support him, but for any reason, he seems to be very frustrated, and just change the horse. Maybe he finds more resonance in this forum. As it is a Facebook forum, I did not join it.
Reiner, what did he get frustrated over?
No, I think Peter.
Yeah, yeah, Peter, yeah.
Yeah. I think he invested so much time, and he's thinking very, very straight, and he's following his ideas. And yes, you see, there is not much resonance in the fourth.
Oh, okay. He's frustrated that the fourth uptake wasn't what he had hoped. Is that it?
I think yes. So if I invest so much time in creating Tachyon and Tacos, and then I'm successful in implementing that in a microcontroller, so that's a really big step. So I think now I reached something, and then it turns out nobody is interested, and people still ask the same questions as they did a year before. So, and okay, I have to include myself. Yeah, I'm sitting in front of the board, and I find no time to dive into it because I have so much to do around in other areas that I now try to push away those work and to spend some time of my life to finally work with Forth and Tachyon and follow the idea they had with the UPN 40 years ago, or 50 years ago. When I believed now that the HP 35 calculator is available, that the whole world will change. Okay, Texas Instrument won.
Well, thanks for the update und einen schönen Urlaub.
Danke, danke.
See you when you return.
Yeah.
Have a good trip.
Yes, I will not drive very far, just over the border to France, and look to find some dinosaurs. And it's a Jurassic area I go to, and I think it will be fun.
Oh, that sounds interesting.
You don't have to move that far. You can find dinosaurs in this forum.
Yeah. Yeah.
Present. Ich bin hier.
Okay. Yeah.
So Chip, you ready to show the clock?
Yeah. So let's see. Let me point to my setup here. We've got a new board here. This is the new P2 Edge. And let me switch my camera here.
This is one of the corner edges.
Let's see. Content. How do I do this? Let's see. Portion of screen. Okay, here we go. This is from a camera here. You see that?
Yep.
Okay, so this is the new one. This is the Ref C, and you can see we have. Can you see my little pointer, my cursor?
Yeah.
Okay, you can?
Yep.
Okay, good. So there are two switching power supplies on this. This first one here, and mind you that both of these can take in 5 to 15 volts DC, which is a lot better than just 5 volts like the last module. So this one here regulates 3.8 volts, and it feeds all of the LDOs that generate 3.3 volts. Because at full load, these little LDOs only need 100 volts above, they only need 3.4 volts to deliver 3.3 at max current. So we used to send about 5 volts to these guys, but that was just creating a lot of unnecessary heat and wasting power. So now that we have these switchers here, we can do it a lot more efficiently. So we give it, more than enough margin. We're giving it a 0.5 volt more than it, well, 0.4 volts more than it would need. But I think that differential probably helps the thing react faster under load. So this thing feeds all these LDOs that drive all the IO pins. Also, it feeds these LEDs up here. Then this other switcher here is generating 1.8 volts. We were testing this yesterday under like some torture test at really high current load, and the thing varies by like maybe a millivolt. It's super consistent. It stays at 1.8 volts, and it delivers all the juice. Then when we come into this board here, we have a PMOS FET, which acts as a kind of a one-way, like a check valve, right? Like a diode, but there's no drop on it. So power comes in, this is like a 30 volt, 8 amp. It's amazing with these, high conductions or these low RDS on values that you can have like a 30 volt, 8 amp part that's that big. Because when it turns on, it doesn't generate heat, it just passes the power through. Then we have a cap to ground. We have, I believe this is a ferrite bead. And then we have a secondary bulk cap. And then off this bulk cap, these two switchers feed. So that generates everything. And down here, we have our new clock. This is this temperature controlled crystal oscillator that's good for 500 parts per billion. And it's a clipped sine 1.8 volt device. So it's running off the core voltage of 1.8 volts. It comes in here to a cap, comes out here, and then there's a series resistor, well, kind of a parallel resistor with the first inverter. So what that does is it squares it up. And then it goes through two inverters that are running at 3.3 volts, and then it goes up here to the XI pin. So what comes into the XI pin now is a super sharp edge. It's like, we'll see, it's about 1.5 nanoseconds rise and fall time. So it's not going to, before we had this 50 nanosecond period coming in as a sine wave from the crystal, and that was prone to re-triggering when there was high noise on P28. Now, and I'll demonstrate that. Anyway, so we have very precise and clean clock coming into XI. And this whole thing now, at 5 volts, this board takes about 3 milliamps quiescent current. And probably half that is this circuit down here. The other half is the quiescent currents from the switchers and the LDOs. But this has like basically a rest current of 3 milliamps. And if you go up to like 10 volts on the input, it drops to 2 milliamps. So if you have the P2 sleep, it takes very little juice. And this thing is always running. It's always putting a 20 megahertz square wave into the XI pin, no matter what's going on. And as we were talking about, this pin here is not grounded, it's floating. So I made a surgery. I was thinking with Michael, like, man, I don't have a good soldering iron, and but I have some eyes I can put on that let me see. So yesterday I made this modification. Well, there. I found some multi-stranded wire, and I took out one strand, and all I had was some rosin core flux, but I wetted the tip of the iron. I touched that there, touched that here, and then just wiggled it back and forth until it came off. So this is ground, and now this is ground, and that let us test out the flash. But this is a desktop part, and it has some funny thing where it's lacking a reset command. So we had to pull the data outline low with a resistor on the Johnny Mac board to get it to boot. And it's kind of a mess, but we need to get the WinBond part. So we ordered 2,000 of those this morning. But I guess Ken probably bought these, seeing that they were pretty much compatible, but we went back to the forum to find out. Someone, I think it was Man at Work, figured out why they weren't working. So anyway, this has an incompatible flash on it. But we were able to test everything with this, and we have these switches here as usual. So I'll show you any questions about this before I change the view.
One more. This is the unique modification you need to do in the board for it to work. The ground wire and a pull down resistor at one of the data lines. Is that true?
Yeah, but that's what we can do to get this working, but there's still some ground signals that are like up here that are not connected. So, like the P59 pull down resistor is not connected to ground. So this switch effectively doesn't do anything. So we'd have to do like another little surgery right around here to fill in for that missing via. But we just wanted to make sure we had the big stuff done. So we got it working, but it's not something a customer would want to mess with.
There is no chance for a drill with a laser in the left side where you can't access over the top, or this is not needed. You can do all the modifications you need using an iron, a solder wire iron, and a few jumpers of wire.
Yeah.
They can all be done. They can all be done by hand with a loop, for example.
Well, the trouble is, like, I think this guy, see where my pointer is? I think that needs to be grounded. I mean, look how tight that is. And then there's this case here has some vias underneath a tab that's below this section here, and that didn't get grounded. So there's just some stuff that's not right. I mean, we got this part working, which was important, but it wouldn't be, it's not worth trying to rehabilitate these boards, I think. And then this is not that good of a ground, you know, compared to what it had on the circuit board. Probably doesn't matter, but we'll get it straight.
I partly lose it. I partly lose it because my connection goes unstable, but I can understand what you were saying. You don't need to repeat.
Well, it might be my connection that's unstable. Let's see, I'm gonna plug this thing into the Johnny Mac here. Let's see. Now, let me see if I have this thing on autofocus. No, there we go. All right, so what I'll do, let's see, I have a program here. Let's see, what was it? What did I call it? Let's see. It was. Oh, well, let's go. There's a jitter test here that's important. Let's see, here it is. Okay. So this little program right here wiggles pins 28 to 31 as fast as it can. Oh, are you seeing? Yeah. Okay, yeah, okay. So this little program wiggles things as fast as it can, which would normally cause a lot of disturbance. So, and we can observe on P1, or excuse me, P0, the net effect of the jitter. So let me connect this really quick. We run this program. Let's see. All right, now what I'm going to do is I'm going to take this thing here, which is, this is a Rev A, right? And so it had the PLL jitter problem. So I'll plug that into this thing. Let's see. And I'll download this program into it. And if we look at the scope over here, we can see there's a lot of jitter, right? Because it's causing these, you know, power supply disturbances in that group of pins. And is that, let's see, let me see if I can also show you what's happening on the crystal here. We'll try to look at what's happening on XI. Yeah, there we have, let's see, this bigger. Okay, so you see we have a sine wave. You see all the noise? Very, very noisy. This is re-triggering as it crosses the boundaries. It's getting more than one clock pulse, which is upsetting the PLL and causing all this net jitter to occur down on P0. Let's see here. Yeah. Okay, so this is the problem we've had. Now I'll take this module out. Let's see. See if we can see both here. All right, I'm going to take this Rev A out and put a new Rev C in there. And download the code. All right, now it's stable, right? No problem. And if we observe what's coming into XI, if I can probe this, you see now instead of a sine, there's a, we can't really, okay, this is only 100 megahertz scope, right? So let's switch over to a 1.5 gigahertz scope over here. Oops. Running out of lead here. Let's see if I can focus this better. Okay. Now I'm gonna probe that same pin.
Affogato. Affogato.
There.
Affogato.
So
Affogato.
hold on a minute.
Affogato. 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 Affogato.
Chip, I don't have muting
Oh, here
control.
we go. Here we go. There we go. All right. So let's see. So anyway, as we look at this, I don't have a good ground connection. So we see there's some noise on the signal, but gosh, is there anything I can do? I don't have the right. Oh wait, can I get a wire on that? I don't think it will make any difference. Let's see. Hold on. No, it's anyway, we can see though that now instead of a sine wave going into Xi, there are very sharp edges. And if we zoom in here, here we're at 1 nanosecond per division. This is 2 nanoseconds. So we have like a rise time of maybe 1.5 nanoseconds. So it's a lot better than before. Now, before we had a slow moving sine that could be interrupted, but this thing slews past the logic threshold so quickly on either side that there's no possibility that it's going to be disrupted.
Chip,
Yeah.
what is the bandwidth with your scope? 250 or 200 megahertz?
Let's see here. It should be, if I go to control setup, channel 1. Let's see. This is a 1.5 gigahertz scope. So let's see, where is
1.3 gigahertz.
the acquisition? Here we go. So we're at 8 gigasamples per second.
8 megasamples per second. It means 800 megahertz. 800 megahertz in analog bandwidth.
Okay, well, if we slow the bandwidth down, okay, let's see here. Control, was it acquisition?
Gigasamples, right?
Yeah, it's 8 gigasamples per second. That's what it's doing now. It doesn't let me, let's see, if I switch to manual here, I go down 4 gig, 2 gig, 1 gig. Okay, so here's 1 gigasample.
Perfect. Perfect. You have almost no jitter. Because now
Right.
there is a comment into the thread about Gibbs ringing. So when you slow the bandwidth, in that case, you are not seeing too much Gibbs ringing as an artifact of measurement. Not real, but artifact that confuses your eyes. Okay, thank you.
Yeah, interesting. Thanks for pointing that out. So see here we can see, here's 8 gigasamples, 4, 2, and then we get down to 1. All that ringing goes away. And then here is 500 megasamples per second. It's like a sine wave.
No. It's too low. Too low.
Yeah. So 1 gig is where it's clean. But see, as we go to 8, it really sharpens up.
Yes, perfect. The part, the apparent noise you are seeing into the high states and low states are just the harmonics. But I don't know. Yes, I don't know how many lobes I'm counting. Perhaps 5. There are 5 lobes above the signal, or there are 4.
Right. Yeah.
When you put the bandwidth higher, You can count. The higher, yes, yes. We have a five,
Okay, so here,
four,
let's see here. Oh, this, tell it to stop. Yeah, we can see there's 1, 2, 3, 4, and 4.
No, 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 it's not 4. It's 5. 1,
Five.
2, 3, 4. No, no, 1, 4. 4. So we have the fifth harmonic and the third harmonic operating right. So don't scary about those lobes. They are perfectly normal, but over the seventh harmonic is not being shown.
Right.
Okay.
You see this down here? We're 117 microseconds out. So I set the trigger. You got to zoom way out, and the trigger is all the way over here. So I did that to show that there's no long-term jitter, or very little anyway. Here's 2 nanoseconds. Here's 5 per division. And then if we just want to try to get the edge, if we really care about just looking at where the edge is, I can go back to 8.
Okay. Where are you picking the signal to read in the scope? From where? From which point of the circuit you were?
I'm looking at XI.
XI, but please look at XO.
Oh, okay, so XO is down here. Now this is a yeah, I wonder if that, I think that noise that we're seeing is because we're swinging pins 28 to 31 so fast. That's what those superposition noise is.
This is
See, if I turn
XO.
off the top of it,
This is XO.
that was XO, but look,
Okay.
yes.
Now
watch
turn.
this. Yeah, what I'll do is I'll go like this. I'll comment this out so that we don't turn on those smart pins. Run that, and then let's see. Now let's look at XI. We shouldn't see that ringing. Yeah, look. No more ringing. So what we were seeing was all the toggling of the adjacent pins that shared the power supply. Whoops, there we go.
This is the XO. This is the XO without neighboring pins being toggled.
Okay, this is XI. Here's XO. Let me go to XO. There's XO.
Yes, that inverter.
It's like a RC driver.
It's floating. It's not connected to anything in the circuit.
Right. It's driving high, low. And let's see, where's the ground at? The ground is right here. We're at 1 volt per division. There's ground. So it's not getting all the way to the edge because it's driving through like a 600 ohm resistor. And then there's some internal loading capacitance, which is slowing it down. That was there for the crystal. So if we had a crystal connected across this, you would see a nice sine wave here, like you would on XI. But because it's just open loop now, we're just seeing the driver outputting into an RC circuit.
Yes. Yes.
And then this is the important one though, that shows what the chip is seeing. So you see, there's like, let me get rid of all this trigger offset, go to 0. Oops, hold on. There. So we can see, here's 1 nanosecond per division. Yeah, it's about 1.5 nanoseconds rise time and fall. So this gets us around that jitter problem. And then let's see, I can probe here the 1.8 volt supply. Although we don't have a good ground, so that's probably when the thing fires and pulls on the inductor.
How many millivolts?
It's 1 volt per division, but see, I don't have ground connected. And this is the 1.8 volt power supply. See here, oops, it's hard to keep the probe on because it's real small.
You know, hello, yeah,
Yeah,
hello.
the average is 1.82 volts. Oh, you know what? I didn't realize, I don't even have my microphone. Is this better? Sorry about that. Anyway, let's see. Is there anything else notable about this? The power supplies work under high load. The jitter problem is solved. We just have some issues with the circuit board missing some vias. So I'll stop sharing this. Any other questions about any of this stuff?
Yeah, I have one again. You said currently you have input voltage around 15 volt possible to the new edge,
Yes.
because one very nice place would be automotive support, and in my opinion 15 volts might be a little bit.
It's low, right?
Yeah.
What we could do though is just
You have sort of spikes in the automotive system which might get higher. Could you maybe somehow get up to 20 volts input just to kind of be on the safe side? Because automotive, that somebody mentioned it in the forum, it's kind of a certification for automotive, and if you could get that for the P2, it would, for the edge board, it would really open up a quite big market.
I think if Michael were here, he could answer, but I think we picked these, there's all kinds of trade-offs in picking these switchers.
Mhm.
And let's see.
There is some sort of specification for automotive. Somebody mentioned it in the forum. A2000 something. It's an automotive certification thing. And if we could get for that board, that might open up a lot of possibilities.
Yes.
You can
It
get
all
to
comes
60.
down to these chips.
No.
You can get to 60 volts when you jump start into the code.
Yeah, the
Right.
load dump on a car can go, yeah, it can go 60 volts. I think
Yes.
to really for a car, you'd put some kind of protection circuit in front of something like this.
Yes, yes, you sure need. You sure need. I made a lot of circuits for trucks and not cars exactly, but trucks to run over the Cordillera dos Andes, the Andes, like the Andes mountains throughout Brazil and Argentina, and they need to be protected that way because
Yeah.
of the low temperatures and the problems about jump starting the trucks.
Yeah. Yeah, I think what we have here is probably a pretty good combination of things, but it was hard. I mean, we had to find, switchers that we feel we can get in the future without too much trouble. And I believe they could probably go a little higher than 15, but Michael probably just said, okay, let's just spec it at 15. I mean, but they might handle 18 or 20, I don't know. But I think it's gonna be this way. I think if for an automotive app, you'd want to put something in front of this for power, and maybe
need a
just
little
give it.
circuit. You just need a little circuit with about six components to do the protection.
Yeah.
Because one single diode is not able to drop enough. 2 diodes in series will be enough to limit, and also some absorbers. Perfect.
Okay, I found that forum post. It's in Parallax semiconductor shortage from CircuitSoft. It's AEC Q100 certified. That is basically the certification for automotive use.
AECQ 100.
Q100. It's a post in Parallax as a solution to the domestic semiconductor shortage. The second last CircuitSoft did it. And I think if we can get that certification, that might have an impact on people using it.
If you like to hear my advice, keep your fingers off from automotive.
Yeah.
It just makes no sense. It's you have to pay any price. They will not pay any price. Yeah, they just let you survive. And it's not that not only you have to have a certified product, you have to find a customer that uses it. And you have to be aware there are many people around that know nothing but how to sell semiconductors to automotive industry. And you cannot compete because you know much more. You are not focused on doing this type of business. What I would have said to the customer from Germany, I would have said it's the propeller is something like a laser. When the laser was invented, it was a solution to problems that don't exist. And problems that are known to be existing, the normal semiconductors companies will have solutions. And then they fight to distribute their processes. But if you come with a product like this, where you have a solution and you only have to look for the problems, it's much easier. But anyway, you have to be lucky to find such a killer app. And for example, if you can drive a motor, that's my opinion. I didn't reach that goal until now. So if you can drive a motor, and you will find a way to autonomous vehicles in the private use, like robots or healthcare robots or something else, then you might have a product that goes to the mass production.
Yeah, that's probably good advice, I think. Yeah, our style would be to someone in the automotive industry would want to use this, and then we would do whatever it would help to get it over the hurdle of qualification, but not go out there pursuing that initially.
Yeah.
So I'll stop sharing this thing. So let's see, what else have we got today? Has anyone got anything they want to talk about or demonstrate?
I got a quick item, if it's okay.
Yeah, of course.
Okay, I got a special problem. And the problem, let me just move my camera around here.
We just lost your video.
Okay, I'm coming back. Someone out there has experience with this. We have here 250,000 or maybe 300,000 or 400,000 through-hole resistors that come 1/4 watt resistors, various sizes, 220 ohm, 1K ohm, 2K ohm. And these resistors need to be cut off of the reels and counted so that we can bag them. What's so funny? You can come over here and help me. So the situation is that normally we get bags of resistors from reels, but the bags of resistors from our suppliers in China. And there's only one brand we really like, and it's Yageo, this brand, because they fit tightly in our breadboards and they don't fall out. This is a big deal in schools. So I scooped up the rest of the 1/4 watt resistors available in the Western Hemisphere and the sizes we need. But now we got to figure out how to get them in bags.
Well, Ken, are they on reels with tape on the ends?
Yes, yes, and yes. And we don't want the tape because that's sticky, and then students have trouble when they put them in breadboards. So we don't like the tape.
I think you need one of those paper cutters that has a chop blade, and just lay the tape down and maybe put something to bind the resistors temporarily, and then chop either side of the tape off.
That's right. I need a machine that counts them and cuts the tape off. Anyone have
I don't remember if the machine counts them, but I seen many of those machines circular shaped, like a rod not like
So you crank them.
a water clock. Yes, yes. You use a hand to rotate, and it cuts. Or if you need, you change the shape, and it will also blend the legs of the resistors.
There's something
But
like
I don't
this.
remember if it counts. You have a definite number of resistors around each turn. So if you had a turn counter, you can count exactly how many resistors you are applying off the strip. And watch out that glue, the glue that you need is then at the borders, because that glue spreads like honey, and will upset your solder machine very, very easily.
Okay, these are going in breadboards. Yeah, we want to get rid of the glue that's on the tape side of things. So it looks like
Please be careful when you handle, because the moisture in the hands or in the fingers will soften the glue, and the glue starts to spread.
I see. And then it's honey. Okay, thanks all. I see some tips already coming in, so I will go do some research now.
Okay, I've been working on the floating point, and I've realized there are some conundrums which I didn't anticipate because of how our syntax has worked thus far for constant expressions. Let me see. I'm sorry, pull a file up here. Yeah, like let me share my screen again. What do you think this is going to do? Let's see. Why did I do this? I don't need this. I was checking, doing something else. So this here. In spin 2, right?
Mhm.
And here is a negative decimal number. But what's funny is, you know, you could have some. So as this goes through the parser, it sees a minus, and it doesn't know yet if that's a subtract or a negation. And then it sees, let me get rid of that 5. We see this would be a subtract, right? But this is a negation. The trouble is the compiler internally doesn't know that this was a float. So when it applies the negation, let's see here.
Oopsie.
I get -4. You see why, right?
What's the reason
Because-
you didn't know it's a float? And we lost you. He's gone frozen.
I would have guessed that the, because having the 0.0 on there sort of indicates that it's a float.
Right, but for some reason the compiler didn't understand that yet, and he's operating before he understands it. That's confusing. There's more to learn, I can tell, about what he's trying to show us.
5. Yeah.
I like that Hackaday thing, Francis. That was cool.
Yeah, I just found that it has a possibility.
Cute little project.
Yeah, these Hackaday stuff come up with some really interesting solutions or other interesting experiments that they do.
Went to interesting lengths to drag the tape through.
Wasn't Chip supposed to get some fancier satellite connection or something at some
I have a
point?
feeling he's still waiting for it.
What, they got to launch the satellite just for Chip or what? What's going on here?
Yeah, really. Starlink deliveries are odd, probably.
Well, Stephen, I have to go to an appointment, so maybe I can make you the host. So if Chip returns, we have continuous video here.
Okay, and it's recording to the cloud.
Yeah.
Okay.
So you can pass it back to him if you want. He'll return.
So I don't have to do anything special, just keep it alive, right?
Nothing. Yeah. Just stay on board till you're worn out or you're done.
Whichever comes first.
Oh, Chip's back. Okay. I'll see you guys later. Thank you.
See you, Ken. Good seeing you.
All right. Boy, I don't know how long I'll be here.
30 more years at least.
Yeah. Oh, you mean on the call?
My internet's probably the worst among everyone's.
The boss has left. It's time to play.
Let's see. Anyway, so there are these syntactical issues where with the floating point that are going to be kind of challenging to overcome in the compiler.
So, Chip, you didn't explain why it doesn't know it's a floating point number at the time you tried to change its sign.
Yeah, where did it go? Let me see if I can pull it back up. Let me share.
Way to catch you up, we're looking at issues that Chip is finding with floating point.
Let's see. Okay, here we go. So if we look at this one, right? If I run this, that's correct, right? 1.0 truncated is 1 as an integer, right?
Right.
But when we put the negative here, we get -4. And the reason is it did a like an integer negation on the float value.
Why doesn't the parser know it's a float value?
Because it just knows all it knows is it's 32 bits and here's the value. It doesn't know the type at all.
What happens if you put in 0.0 minus 1.0 and then put it as a sub-expression in parentheses?
Okay, let's see here. Still the same thing. Because 0 is 0. If you take 0.0 in floating point, it's also 0 in hex. But if I did something like maybe this, let's see, does this come to 1.0? No, that comes to 0. I just don't have any awareness of type. And so when it sees this negation, it applies an integer negation, not a floating point negation. Now, the way around that, I'm going to have all these special operators like this, right? But that's kind of ugly. Would anyone mind typing that? Would you like to, I mean, what would it be like to always have to express negative decimals like this?
What about a trunk float?
Let's see, trunk, okay, oh, yeah, so float, how about we put 1? Let's start with 1. Good, we got 1, right? In fact, let's just make this unsigned, or no, signed decimal, all right? So I equals 1, it came back as 1. If we make this -1, this is gonna work, I think, yeah? Because it converted it to a float, because it did an integer negation right here. But when we try to do a minus, see 1.0, let's just say I equals 1.0, right? And let's make this unsigned hex so we can see it all. It's 3F8000. If we make that negative, what it did is it should be BF800000, but it negated the 3F8000. So, and I don't have this stuff, I don't have this kind of thing working yet, but I just have to get in there. What I'm going to do first is get this working, so this will work, right? This knows that this here means do a floating point negation. But it just looks awkward to do that. I mean, you might have a variable there like X, that'd be fine. But
it fits the pattern of your other commands that you're going to have a dot on, so it seemed like it's reasonable.
Yeah, it just looks weird. You'd have to do this. I mean, everybody would, you know, this would be a problem for everybody until they figured out they need to do this. But what I could do, if I could have the compiler be more type aware as it goes through things. And once it realizes that this is a negate, not a subtract, and then it can go, what am I negating? Oh, it's a floating point constant. Then it could properly do it. So you'd only have to specify this. But now what it's doing,
You keep identifying a negate versus a subtraction. What's the reason you keep those separate in your mind?
well, because you don't know what's going to happen yet. There's order of precedence and all these things going on. So you go through and you elementize the stuff that occurs in the text. And so what it sees here is it sees, okay, there's a variable called I, and then there's an assignment operator, then there's a minus operator, then there's a floating point value. So it processes those kind of in RPN form. Right?
Is there, the reason I'm asking, is there any case where a negate is any different than a subtract from 0? So is there any simplification to be made by just rewriting the math internally?
No, I don't think so, because see, at the time I elementize everything and I identify like the pieces of the text, it doesn't know the context. It knows that that minus is a minus, but it could potentially be a negate. It's not until we get deeper into the parser where it goes, okay, that's a negate. Now, if we put something like this,
because your terms are, your
yeah, I mean,
is different.
this would be different, right? Then that's a minus. But see, it's because it already encountered some term. So if it encounters a term and sees that, it knows that it's negative, or it knows it's a subtract. But if it sees that first without a term in front of it, then it knows that must be a negation. But it doesn't happen until this has already been resolved. Does that make sense? So
It does.
Yeah,
So it's all about your parse tree and order of operations.
yes, yeah. I mean, my first instinct was, oh, I'll just, you know, when I see a decimal number, I'll go back and look for a minus sign in front of it and use that as a negate. And I was completely forgetting that might be actually a minus operator, a subtract operator. You know, so you have, this only comes up later in the parsing process. It doesn't happen early on. Because it could be expressing formulas. Yeah.
Hi. That's the reason why I make all my routines, my floating routines in strings, because I I can identify it is a negative number or a minus math symbol. If the negative number is close to the number, means that it's a negative number. But if I have a dash between two numbers, I identify that is a subtraction.
Yes, yeah, I remember you explaining how all that works in your system. In this case, though, we have packed, 32-bit packed floating values. So there's not enough memory to do strings or anything like that. It's all.
I can make mathematics with infinite decimal points.
Right.
Or number, because the string can be a big, the size that I wanted, because I identify, in the string with the dot, the right is decimal, the left is the integers. So I made my mathematics, my addition, subtraction, division using strings.
Right.
Yeah.
Yeah.
So I don't have that problem to identify if a minus number, and the minus numbers, when I do addition, I convert those to positive. Multiply by 2, and then I made the mathematics.
Right. Right.
I always I don't make results with negative number. I convert everything in positive, and then if it is a number that is a negative, I add at the end to the string a negative, a dash. Is the first thing that I add to the string, the dash and the number.
Yes.
And that's the way I made it.
Right. Yeah, that works.
It's complex. It's complex if you using numbers with variables, but with strings is easier. It's around 4 routines that I use for that. It's not a short program, but I made it, and I use it for reading voltages, current, with a precise number.
I could do something in my case, like when I understand that it is a negate. See, the trouble is at this time I've already lost my place about where we are in the text data, because now I'm dealing with like tokens, that are in some order, and then I'm having to convert them to RPN to solve the equations at runtime. So everything's like jumbled around, and you've lost like information about, where did that minus appear? Otherwise, if I knew where the minus was, I could go back in the source code and go, is the next thing after white space a decimal digit? If it is, then I know it might be a floating point, and then I can go and look for an E or a decimal point, E for exponent, and then I could resolve it that way. But I'll come up with something before it's put to bed. But as I get into this, I realize there's all these like subtle little issues.
Chip.
Chip.
Oh,
Yeah.
one of the things you mentioned was that if you leave the information flow from your string processor to your parser right now as it is, you can't tell the context. Do you have an ability, as you were just talking through, if you're recognizing it the string, do you have an ability to do this operator substitution at the string processing level so you can inject the minus dot?
Well, I think when I'm processing the strings, I don't know how this all comes through the RPN conversion. Because things can get.
I understand. Yes, I understand that. Well, what I'm saying is if you were to pre-process the strings and recognize the context and maybe do the minus for minus dot substitution right there.
Yeah, the trouble is it's very contextual. I mean, I have to figure out let's say there's some characters. I have to know, is that a variable? Is it a term in an equation? Is it?
You're right.
I don't know what it is until we go through the translation to turn it into tokens.
Yeah. And so and by the time you're at tokens, you've lost the information you need.
Yeah. What I need to do is have extra information that carries with the data. Like
Right.
this was a decimal number.
Right. That's
Enrique.
your whole type issue.
Yeah.
Chip,
Yes.
there is an easy solution, and you can deal also with minus and plus, because sometimes people write the plus in front of the numbers just for remembering they are positive.
Positive. Right.
Okay, just treat it as a parenthesis, another kind of parenthesis. So if you have a minus or a plus in front of a number, you open a level of parentheses that, if not closed until the expression is finished, means that it's on a signal. So you can deal with it just like you deal with parentheses, but to another level. It's very simple. If you have a rule to deal with parentheses, because you need to count how many you have open before, and you need to check if you closed enough number of parentheses at the end of the expression. So if you open another level with the same treatment with those front signals, you have the solution.
Yeah.
Because at the end of the solving of the equation, there is still one open level that is not closed. And if that level is a plus or a minus sign, you know they are just about maths, the way people write things. So, because I can write this like minus and minus 1 multiplying a 1.0, and it will work. So if you open a level of parentheses that is not exactly a parenthesis, but it's the one for dealing with minus and plus expressions in front of number, at the end of the expression, that level is still open, and you can solve it. Oh, that minus is only to state the signal of the number. I use it at CompuCorp in 1975 because some of the calculators we had don't have decisions. They can't make decisions. They can do 160 steps of program, but with no decisions, only maths. So I need to be creative with equations to eliminate such kind of problems by multiplying or using the numbers that have no sign. What is a number that is always positive? It's
well, like I don't know. Positive.
Question. I have a question.
Please repeat.
Yeah, I have a question. What is the biggest number that you can process in any arithmetic operation? 1,200,000,000 something, right?
Yeah, well, for floating point, it's like something times 10 to the 34th to minus 10 to the 34th. And then for integers, it's, minus what, 2.1 billion.
Okay, do you have any bit of the 32 bits free?
No.
No,
They're all used up. That's the whole point of floating point. I mean, it doesn't even, there's an implied leading one that goes in front of your mantissa that isn't even stored in the floating point value. So they've done everything to make it super tight. They've squeezed everything they could out of it.
Yeah, no free bits.
Yeah, we'll get through this. This was just, and then, it's just, as I get into this, I'm realizing that we have some precedents for how floats are handled in constant expressions, like in con blocks. And,
Right.
and what's going to happen at runtime is going to be a little bit different. So it's kind of I don't want to make a kludge, but I can't break everybody's old code either, you know, and force them to do some standard operator usage for floats in the old con blocks they've already written that contain floats. You know, we can't disrupt that. So the runtime just has to be different. I mean, this is the easiest thing. You just have them do this.
Right.
That's not too bad, but if they do this, it looks really confusing to someone who shows up. It's like, what is that? Some kind of multi-dimensional number? But, you know, this looks a little more sane, right?
How many operators are there?
No, I don't know. I mean, right now I just have, you know, these. Whoops, that should be a, we have multiply, divide, plus, minus, and then this could also be negate.
Okay.
And then there's,
Well, that actually reads pretty well then. It's as odd as it looks. Because it's the same operator, it's going to work pretty well. We'll get it in our head.
yeah, but if you do this, you're never going to realize what went wrong because the bug that creates is so bizarre.
Yes.
And it, you know, it just doesn't, it'll drive you nuts. So you have to know that to do it with the dot.
We're going to have a sanity. We almost have to have a sanity check for, are we playing with floating point numbers? Are you using floating point operators?
Right. I mean, if you do a variable thing, like if this is, you know, this is going to do something way different than this, right?
Yeah, of course.
You know, this will treat X as a floating point. This will treat it as an integer.
Right.
So this one just toggles the MSB, and this one negates and increments the whole 32-bit value.
Sure.
Yeah,
it sounds to me like you've got a good solution and we just head forward to implementation.
Yeah, I think this is the way to do it, just like this. And that's consistent. But see, in con blocks right now, you can do stuff like this and it doesn't, whoops, you know, it'll properly resolve stuff like this in con blocks.
Right.
But that'll just have to be some kind of legacy exception to the rules because the runtime rules have to be a little different.
Yep. That stands to reason.
And then this will be able to resolve into a constant because I have the expression resolver test to see if it can solve things. And this will be solvable at compile time.
Nice.
But you know, this one is not.
Of course.
Yeah, okay, so that's what we'll do. We'll just press forward with the dots on the regular operators. And that's the way forward. Some of these things, you know, they present technical problems and there's these things that would seem like the right thing to do to get around it, but then you just create another disaster.
Yeah, exactly.
So sometimes it takes like a day or two of just like, you can't write any code. You just have to go do other stuff and let it percolate in your brain until you realize, you know, this is the right way to handle this problem.
Yeah.
Because if you did make an exception to allow this, then people would also think you could do this.
Correct.
And you got to like try to come up with some consistent story that they can think with.
I think you've got a solution.
Yeah, it's good to talk about stuff. Part of, you know, one of the big values in even talking about anything, even with someone that doesn't know sometimes, is it's like you what's that? You spool it out, right? And then it goes out and then it comes back into your ear. And just that process is aids in like organizing things.
Absolutely.
In your own head.
Sometimes you just have to verbalize it to understand it from more perspectives.
Sometimes it's even enough to write a forum post, and when you are finished with it, you know the solution. Writing it down or kind of telling it to somebody brings you to concentrate your mind on the problem you actually want. I mean, it kind of centers. And then usually, I mean, I often explain things, and if I have explained the problem, I have the solution. Because I basically, yeah, by concentrating it down to the problem, you basically find the solution. And that is what happens when you talk to other people to explain your problem or write a post about how can I solve this bullshit. And then you finish with a post and say, ah, yeah, sure, I know. It's a mind thing. But I think honestly that the consistency in doing a dot behind the operation is more important than the mistake somebody can do by typing -1.0.
Yeah.
Point to less. You know, it has to be -1.0. That is something you can get used to, and it's for sure way more easy to handle than add float, you know, the method thing. I mean, now you can write an expression like an expression should look, and not doing method calls to simulate, and you know, the current version of float 32 or whatever requires you to write kind of weird thing instead of just an expression.
Well, yeah, you don't get the benefit
Putting
of
just a dot behind the operation, it's consistent. It's a floating point operation. It's a point.
Yeah, then you get to have precedence, operator precedence, which you don't have if everything is a function.
Right. Yeah. And it's easier to write, I mean, and easier to read. And I don't think that a dash point is that problem. I mean, all of them have a point behind it, and so you can get used to it. It's kind of a regular thing, you know.
Yeah, this is good. And it's also good to not allow, I mean, to allow this, but then not to allow that.
No, that's wrong, right?
Yeah, that would cause more confusion. So it's better just to do this.
Yes. I think it's simply cleaner. Sure that they have to get used to another sort of operator. We have different float operators, but you can get used to that pretty quick, I think.
Yeah. You know, I wonder if we should have things like, you know, we have actually 3 versions of every math operator right now, because you can do, like, say plus, right? You can say I equals 1 + 1, right? Or you can say I plus equals 1. These are all, I mean, in the interpreter, these are all different byte codes. And then you can say like within an assignment, you can say like 4 + I equals, you know, A times B. You know, you can do buried assignments. So this kind of operator here, what that does is it's like this one here, except it leaves the result on the stack, right? So that it can then be added to 4. So for plus, there's 3 different plus operators. There's one that just does a straight plus, leaves the result on the stack. There's one that drops it from the stack because it writes it to a variable. Then there's one that writes it to a variable without dropping it from the stack. So I don't know how far, I mean.
Something I think spin is confusing me a lot with that an assignment also returns a value. I mean, it's a cool feature, but it's.
Yeah, well, it can be, you have to know it, but look, do we want this? We want this. I don't know if we want that.
Yes, we do.
We.
Oh, that's weird.
Here, this would increment, oh, wait, we'd really need to say, this would have to be a float, right? So you'd have to say like that.
Yeah.
Do we want, but really?
Yes, technically, yes, and it is the correct notation.
Do
If
those
you,
operators exist in other languages with floating point?
Well, they put, I mean, they would just say plus equals, because they have types, right? We don't have types. So if we want to do this with floats, we better say, you know, that it's a float. You have to, it's just 32-bit data. The operators completely define what the data, you know, how it, what its representation is. This would be like integer, right? Like this. And this would be the float version right here. I mean, that would mean we'd have to have 2 more byte codes for every possibility. I don't know if we need to do that. I mean, I think for the floating point math, maybe it's sufficient just to say, like, you know, make them do something like, whoops.
Thank you. That would have hurt my head.
Yeah, I mean, that's pretty straight. Oh, wait, this has to be like this.
Right.
right.
So these two are the same. Question is, do we want the support?
Does it do much to your overall size?
What's that?
Does it do much to your overall size if you?
Oh, like of the interpreter?
Correct.
Not necessarily. No, I think I could do it pretty efficiently. I mean, we just have to, you know, write things when they're done, or not pop them from the stack.
Right.
It's really not a big deal, but it does mean, though, that we have to have byte codes for all those different things.
Yeah, my question is, I mean, you said you have different byte codes for plus equals, and I mean, that I equals 1 plus 1 instead of I plus equals 1. Why do we have different byte codes for that? I think I followed Eric's comments about FlexBin, and he said his optimizer basically reduces expressions so that they produce the same result. If you type I plus equal 1 is the same like I equals I plus 1, and he basically reduces this down in the in the parsing state. He already optimizes it down to the same equation. So I don't see that you need different byte codes for plus equal, and you can reduce it to the same.
Well, we're not, here's the thing though, his compiler is super smart and has a giant code cruncher in it that can, you know, analyze things and break them down.
And do the reduction.
Yeah, do the reduction, yeah. Whereas we don't, here the programmer is writing code that's reduced. Because it compiles.
On the other hand, or maybe extended, that I plus equals 1 would be expanded to the form I plus I equals I plus 1. I mean, you can expand the code to the same form.
But Michael, what are you saying is that he doesn't have the expansion and reduction pass in the interpreter.
Okay.
Right. So it's
it can't be done.
What you see is what you get.
It would be in the compiler, that the compiler kind of parses the text string and said, okay, 1 plus equal 1, I plus equal 1 is the same like I equals I plus 1. I mean, they don't need to be different byte codes. They could be textual replaced.
Oh, yeah, you're right. No, we could handle that using like longer form assignments in other byte codes. You're right, we could do that. I mean, that wouldn't require any.
Just treat them as the same in the parser state before you can, I mean, just replace I plus equals 1 with I equals I plus 1 in source, and then you just need one because you have the same form. Then you normalize it in one or the other direction. I don't care, but basically you can parse the source before you. And I mean, we need a pre-parser anyway, so that you can do all those if-def things which you are missing still. Which is pretty nice feature of BST and C, that you can say, yeah, that pre-parser thing basically, you know, that is something which is missing in Peanut and Prop Tool anyways.
Yeah.
Define if def underscore P2 do that, else do that. So you can have in one source P1 and P2 assembly and just switching by kind of a constant in kind of the pre-parser thing of C and yeah, we should do that in Prop Tool also. I mean, BST is doing it. That's the reason why a lot of people use BST. That if def something do or do something else.
Right.
And that would help. And I mean, yeah, take that C. I mean, there is some C preprocessor you probably can just attach to your source before you run it with some rules. And expanding or contracting the source to a more machine readable form.
What I'll probably do is I'll probably, at least first pass, I'll just make the raw operators out of these extended hub bytecodes. And then I'll have Tyler, rather than select a special version of that bytecode to do this, I'll just longhand it, you know, so that if they say, if they write this, I'll just do, well, no, maybe I should have the bytecode.
You expand it to the long form, basically.
The challenge would be, Chip, is that you're pulling things off the stack and putting replacements back on mid-context, aren't you?
Yeah.
That's gonna, it's kind of an interesting issue.
Yeah.
Yeah, that's the reason why I think a preprocessor of the source would help out, because then the compiler doesn't even see the short form. The preprocessor could expand the short form to the long form, and then your compiler just have to care about I equals I plus 1 and not plus equals.
I think we understand that, Michael. We just don't have it yet today.
In the preprocessor in the source file, basically, before you use it. So it would reduce the number of bytecodes needed.
You know, maybe I'll just put the extra bytecodes, because think of this, those operators that are floating point, that are subject to precedence.
Yes. Oh, we lost.
You have to read about the square. It always does the same thing. Can you hear me now?
Your feed paused. So you were saying those operators that, and then we lost you.
Okay, I was saying, what was I saying? I'm not remembering now. I don't know, but as I get into this, it'll become apparent what the best way to go about it is.
Right.
It's always like that, though. You never know until you get into it. This idea that you're going to write a spec and then build something always seemed like a complete head grinder to me, because you just don't know how to best get there until you start on the journey. You know, you don't know what you're going to encounter.
Yeah.
Kind of pie in the sky to write a complete spec at first. I guess could be done, but I don't know.
How do you have any sense for? I think you just admitted that you don't, but do you have any sense for how this is closing for you, or you expecting to find more open issues?
Wait, how it's closing for me? What do you mean?
By closing, I mean that you found what you're going to find and you're finishing the implementation. I guess by nature of the very question is you don't know what you haven't found yet. in terms of you just found this negation issue, right?
Right.
Yeah.
And so you just have to go through and implement that and see what's left, I guess.
Don't anticipate along the way, and then I got to deal with those and sometimes backtrack and do it differently.
Right.
Yeah.
Nice.
It's all-
As you find these cases, are you just, I think what I've seen over time is you just build all these cases and make sure they compile clean, and you leave them in examples that you're writing. Is that how you're doing this?
Yeah, but I mean, I added into the documentation too, right? So that it's explained. I always explain everything in like all the detail that anybody would ever need in the documentation. But I guess I write tersely because sometimes people complain that there is no documentation.
Yeah, that's fun. Okay, so I also see that as soon as you get close enough, I'm gonna be using what I did to just to catch you up. As I was making sure my parser was working, I took all the code examples I can find all over, but I also took all the code that you had put in the manual, the Spin2 manual, and externalized that into files and made sure I could parse everything you were doing. So I suspect there's going to be another pass as soon as you get this cleanly documented, that I have to make sure my parsing under VS Code is going to work as well against your floating point.
Right. Yes, I know what I was gonna say.
Good.
Okay, unary operators don't really have much precedent issue, right? Because they are tightly coupled to what comes right after. So only binary operators have precedence rules. So it really wouldn't, I mean, what do we have that is binary, that is for floating point, that's not a function? I mean, a lot of stuff like power is going to be a function that's going to be kind of encapsulated in parentheses. And so the only stuff that really winds up being subject to precedence rules is multiply, divide, add, subtract.
Okay, good.
And so that's not many, right? So it's
Right.
not going to break the bank to just implement all those discretely like I did for the integer operators.
Right.
That's what I'll do then. And that'll keep the parser simple, really simple.
I like the way you're thinking about it.
Yeah, it's the thing, I can't think about it until we get to do it and talk about it or think about it. Then it presents itself, but otherwise I have no idea how it could work until you go down the road.
Well, I think the community is excited that this is going to appear, that's for sure. I know I am.
It's taken me forever. I was going to have this done 3 months ago, I think, on like a Friday, but I was both underestimating it. And then I was also kind of like, I've been in somewhat of a vacation mode for like 3 or 4 months, you know, just kind of, I don't know, not burned out, I think, but just thinking about other things. And then Doug moved all of his machine shop in here. So that's been something I've been kind of involved with. So I need to get back into this. I really like doing this when I'm onto it, but I've just been off of it for a while.
Yes. Nice. Good.
Yeah. What else? Does anyone have anything else they want to talk about?
I think the most efficient way to solve your parsing problem is to use a binary tree. Are you using a binary tree with tag IDs for let's say operator precedence? Right. There's a way of doing it that's really elegant that solves pretty much any order of operations, rather than trying to do my dear Aunt Sally and have a bunch of nested loops. How are you actually doing your operator precedence?
It's funny because what it is, it's a bunch of like re-entrant routines that can call themselves. So it all kind of resolves on the stack. I mean like the runtime CPU stack is where everything gets pushed and return addresses go and they get popped off on return. So like if you're deep into parsing something, you might wind up calling the head get expression parser to get some term you need for something that's in a parenthesis. It's part of an equation. So it's not like a data structure. The data structure exists only at I guess compile time on the stack. You know, I mean, the CPU stack holds all this stuff. Does that make
Okay,
sense?
so this is strictly during compile time, not during runtime. The interpreter isn't looking at this. The compiler is,
Yeah.
it's like,
just-
yeah.
Yeah,
There's a
just
way of doing
compile.
that with a binary tree that doesn't do all that stuff. Because when I was in college, I took that class and I had to do algebraic to Polish and Polish static evaluator. And I did it the exact same way that you did. And then I realized it can be done with trees. And trees can handle cases that have hundreds of levels of nested priorities and things. It's like you take something like, you know, if you were processing text, imagine you have a priority where verbs are more important than nouns and nouns are more important than adjectives. So if you were to take a sentence like in the beginning God created, you put in 1, the 2, beginning 3, God 4, created 5, that's a verb, the heavens and the earth, blah 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 blah, right? So what you do is you put a tag ID, which is where it is in the document. So you just like taking a document, you turn it into a linked list,
Right.
and then you have a bunch of dictionary pointers. Then you put a tag ID that says the word created, the word God is word 4, created is 5. We've got a the again at position 6. So we have a dictionary and we know where each word is in the document and how many times it appears. Then what you do is you go through and you say, let's find all the verbs and put them at the top of the and feed them into a binary tree, right? Self-sorting binary tree. And then you go for your nouns and your adjectives. And what's weird about binary trees is your tree algorithm isn't looking at the word, it's looking at the tag ID. So everything appears in the original order, right? But you can also do that with operator precedence, so that if multiplication and division comes first, you put your multiplies in the tree, and then you put your additions and subtractions, and then you put your variable names. And you can have 100 levels of precedence if you want for different operators. And then when you go to the bottom left node of your tree and you walk the tree, it gives you your string back exactly the way you entered it into the system. So that's when you do it, you know, in order traversal. But when you go top down, breadth first, that's your reverse Polish.
Yes. Yeah, I think I have integer values that denote precedence that are part of what gets pushed onto the stack. And it kind of like, I forget, it is pretty elegant. And all this tree business is kind of realized in the call pattern. And it's, I don't remember how I figured it out, but it was kind of revelatory and it works. And it's pretty simple as is. I'm just not storing a whole lot of other information like, you know, where did this particular operator appear, like, you know, in the source code. I'm not storing that stuff, but it hasn't mattered. I thought it was mattering here, but in talking to you guys, I see that we really need to say minus dot to do a negate on any kind of floating point value anyway. So it's back to like not mattering, that there's not much information, which is kind of cool, because if things are like as simple as they can be and then they work out through rules, that's always kind of nice because it gets to be easy on our brains too at the end without becoming too Byzantine.
No, I basically like that dot notation. It's a good idea. Power and stuff like that. That's a question with your trunk you had in your example. Wouldn't that trunk know that the value is floating? You can't trunk an integer.
Well, it could be, the trouble is it could be a whole expression with calls to
Okay. Yeah. All right.
Yeah, there's no telling what it would be. But it turns out to be not too complex in the end. But if I go back into that thing, I have to look at it for a day before I figure out how it works again.
Yeah, and then the classic question, what is about the spin compiler and spin?
Well, that would be good. I'm kind of thinking though, I'm waiting to have, I feel like there's some possibility to do some kind of like hybrid, textual and graphical, some way to express code that doesn't tie your hands. I mean, it doesn't limit you, but it also makes it so that a stranger could understand it. I just feel like someday
Okay, I have a good tip for you there. Use names for your stuff which have more than 2 letters. Then somebody can understand your code. Just
yeah.
vertical counter and not VZ.
Well, maybe in an ideal language, you don't even have to make names if you don't want to, because maybe there'd be some way to connect stuff together so that there's no need for a symbolic name, kind of like a schematic. But the trouble is those become binding and difficult and clunky and hard to get around. But there might be some kind of hybrid way to do things where you can, compose functional code without, because naming is like a huge problem, just coming up with names. And then is it a verb? Is it a noun? Is it descriptive, or does it describe the action and blah, blah, blah.
But the main point, Chip, it has to be more than 2 letters.
I know. Well, but it might just be a line that goes down and connects to something else. But then maybe we need like more than 2 dimensions to show what it is that you're building so that the paradigm works okay.
Yeah, that Nick's guy here with his ConnectX idea, he has kind of a mix. He claims it's Gantt diagrams. I see it more like the logic thing. He is basically expressing different instruction flows in parallel lines on the screen, and then put in boxes for connecting. He talked about that in the last Zoom meeting. I basically find that idea pretty attractive, except that in large programs, you need a very big screen to zoom in there and see it. It's like the same as Blockly. You can do nice things in Blockly, but as soon as getting too complex, you need a monitor setup like you have with 650 by, I don't know, 6,000. You need a large screen to see it in graphical representation.
Yeah, see, here's my...
Yeah.
I got new TVs recently because one of my old ones died, and I couldn't buy that TV anymore. It was like from 4 or 5 years ago. So I got these new Samsung screens, and I built a bracket that bolts across the back of all these things and makes them like a trifold picture frame that just sets on the desk. So there's no need for mounting on walls. And these are like 45-inch monitors. What I had before were like 49, and they were just high enough that I was like always looking up too high. But now I don't have to look so high to see the top, and the color quality and everything's way better on these Samsung screens than they were on those, no-name Chinese Avera TVs. They were okay, but these monitors are better, and I just got them at Walmart.
Yeah, I'm building my man cave right now. It's one of the reasons I took all that wood from you, because I will need a lot of wood there. And I'm currently building my new desk, which is kind of workbench and desk together. So I also think about getting those TV monitor thingies that you have, because I'm envy. Envy.
Yeah.
I saw them live, and it's kind of honestly a nice setup you have. I saw the old one, I didn't saw the new one, but basically it's except that you always have to look up, and that will
Well, this is as high as I have to look now. I used to have to go like this.
yeah.
I only have to tilt my head back a few degrees and look up with my eyeballs. It's not
Okay.
bad.
Yeah, because that hurts the neck after a while. I'm thinking about how tall I was once then. But yeah, I like that the setup you have. It's kind of intriguing.
Yeah, these Samsung screens are way better.
Yeah.
But what you were saying though about you need screens to like big screens to look at graphical programs, that's true. And see, there's something so elegant about 7-bit ASCII or 8-bit ASCII, but you have to have like the mental models in your mind to know what the patterns of characters do and mean. So it's not easy like Blockly. There's some stuff you have to know about. But it would be neat if there was some kind of way to do this in some hybrid fashion where you had nearly the efficiency of 8-bit ASCII, but you also had a deal where you could take someone off the street and ask them to fix the problem and they could approach it. Like you could do that with Blockly. If you had some machine that was running, someone could come in and look at a Blockly program and go, well, they start clicking on it and making changes and observing what it does. They could change things around. But with ASCII coding, it's very efficient. If you know it, it's easy, but you have to have the dictionary in your head. Whereas Blockly, the dictionary is just on the left side of the screen in a column. Anything you can do, you can pull out of a set of blocks that you can snap together. So that's real nice. But of course, it's hard to do some complex things like that. But it's easy to do some things that are kind of complex. But it's just different. There needs to be some mixture or some all new way of expressing code where you don't have to have the whole library in your head when you write the code.
I'm not sure about that. I think if you want to solve a problem, you really need to understand it. And if you just guess and just put blocks together, and I don't, especially on microcontrollers, you have to do that fine tuning a lot, and you can't do that. That's what I kind of dislike on the Blockly thing. I don't know. Maybe I'm too old school. I mean, I'm a COBOL programmer. I'm writing compute count of customers divided by. I mean, I write that down. It's not a dot or a dash or divide by number of customers.
Right.
COBOL is very, very text intensive, and since there is no scope in the language, basically, you have to be very careful with your names so that they don't overlap. You can just have one I.
I know, but in naming though, you might just want to like in code, just go jump a few lines ahead. So you got to come up with a name for that. And that's like always kind of taxing. If you could just like draw some kind of like bungee connector that goes down there, that would save the headache of having to make names all the time, which would free your brain up for more getting into the mechanics of what you're trying to do.
Oh,
naming
wrong. COBOL is the most expressive language, you can say, but you don't need to comment it. You can basically read it. It's almost like English language. You don't need to write. There are rarely any COBOL programs needing any comments on the left side, right side, because the way the language is writing things is so expressive, because you need to have unique names. you don't need to comment anything. You can read 50,000 lines of COBOL without any comments, and you can understand what it's doing. Because the programmer is bound to name things because there is no scope. You can't use an A. You can use a variable called A one time. I mean, but on the long run, you don't. You name things like they are, and then you don't need to comment. That's in my opinion, something all programmers should understand, that if you could put good naming into your Johnny Mac is a perfect example for doing that. You can read his code because you know what that thing. If I look at your video drivers, I'm stunned with 32 two-letter variables. Why don't you call it horizontal whatever count instead of HC, or just to name it?
Yeah.
Tell the reader what it's doing. And that is, in my opinion, COBOL doesn't give you any scope, or kind of less you have, but basically you don't. So you have to do it, and that brings basic. I'm working with code which is written by people who are dead since 20 years, and I can read their code. And can work on it. And that is because COBOL pushes you to name things, else you couldn't handle it.
Yeah, that was really prescient. I mean, that language is 60 years old probably, right?
Yeah, way more. Around 1956 or something.
56.
Yeah.
So
I'm working with code. Actually, I'm not a COBOL programmer anymore. But sometimes they call me up and I go there, Then I have to wear a tie and shave and all that stuff, But still, it is, you can easily read code written 20, 30, 40 years ago. It's a long read, sure. But the language requires basically the code is the documentation. You don't need comments.
Right.
And that is something which I'm really missing on other languages. You can write expressions way shorter, but then you need to explain what you're doing in the comment line so that you know what you did 5 years later. Who wrote that shit? Me.
Michael.
Yeah.
Wasn't it because COBOL programs need to be checked by accountants?
Oh.
Yeah, sorry, I had a call. What again, please, Enrique?
Isn't it because COBOL programs need to be cross-checked by accountants that don't know nothing about programming, but can do a good reading of books?
Yeah, actually, that is part of the whole COBOL thing, that kind of accountants or other people are able to read the code and understand it. So it's kind of, you can't write 1 = 1 + 1. You have to write I add 1 to COBOL or whatever.
Yes.
So
exactly.
For somebody who is not able to program, he can read those computing statements and say, yeah, that is exactly what we are doing in our accounting system. He can understand that calculation part because it's basically written in English language, and it's not written as a formula or kind of method call, whatever. It's just compute number of customers equals giving percentage.
Yeah.
So it's readable for non-programmers. That was basically the main intention in COBOL in the first time, because there were not many programmers, and oh well. Did you know that fact that since 1950, and let's start in 1946, we had one programmer, probably two in the world. And since then, the number of programmers basically doubles each year. That also means that now, if you kind of look at the current workforce of all programmers in the world, 50% have 2 years, at least 1 year experience. 25% have 2 years, 3 years. 10% have maybe 10 years experience. You know, the number of programmers doubles every year, and none of them have any experience. And that's the reason why we have Windows updates which fuck up your modem and whatever. There are just tons of maniacs programming without any. I mean, I'm doing it since 30 years. I'm in the 2% range or something, like a lot of you guys here. But actually, 50% of all programmers in the world have just 1 year experience. That explains the sad stage of software.
That explains how there is a lot of virus spread, because the people that are doing programming don't realize all the details of the things they are dealing. So they don't protect efficiently what is really important into the data the code is dealing. They look at data as a packet of cigarettes, and you just open the packet and smoke a cigarette. You are consuming data like you're consuming Coke or cigarettes. You are not looking at the inside of the cigarette.
Yeah, that I think is. I was teaching for a while. I was teaching. I never wanted to teach, but I was bound to do because some friend of mine got sick and I had to take over his class, and so I was teaching 36 people COBOL in. It was in Germany. I had to go back to Germany for that. It is amazing how the mindset of people is, for me, sometimes amazing. Let's say about 50% get it and 50% don't. But those who get it, they can get further. But you need to have to give young programmers, you have to kind of really nail down the thing, naming and I mean that blockly thing is nice for schools. You can see the structure of a program, the flow chart or whatever you called it in the 50s. But the main thing on programming is that you do a mental abstraction of the real problem into a mathematical solution on the end, sort of. And COBOL is nice for writing it in English, but I basically, I don't know. I went out of teaching again, you know, like I couldn't handle those people. But it's a concept you have to have in your mind, and Blockly will kind of give you that graphical view, also connecting here of Nick. It's a good idea, in my opinion, to understand the control flow, but I don't know. I'm down to ASCII code. I like code.
I do too. I mean, it's amazing what can be done with just simple ASCII, and it's easy to move around. It's easy to save. You know, there's no special app needed. Lots of apps can be used. But there must be some other, I mean, maybe we're kind of limited on what we can imagine because we have these two-dimensional screens that can show three-dimensional information, but you know, it's with some limitations, but the whole way everything is set up, ASCII seems to be the most economical and flexible.
ASCII with 2 eyes. So we're talking about 8 bits and not 7. Yeah, please. I have that problem with that COBOL group right now. They are developing on Linux and they mostly ignore the Windows part of it. It runs on Windows, but you have to use that GW kind of Linux POSIX system on Windows, basically. And they still work with 7-bit ASCII. So you don't have the German umlauts or, you know, kind of no, I don't know.
Well, if you don't have European characters, 7-bit ASCII is sufficient.
Yes, but if 8-bit is way better. I mean, I like the Propeller font with all those graphical symbols and stuff, you know. No, 7-bit ASCII is not enough. But anyways, back to what I think. As soon as you have an edge with HyperRAM, which is, in my opinion, a very important product for you. Arglo Roger has kind of a driver ready. But if you can push the video RAM out of the P2 RAM, which is basically what he is doing with his driver, you have a lot of resolution on the screen and almost no hub RAM left. I mean, almost no hub RAM used.
Right.
So that I think that edge board with HyperRAM or whatever RAM you are putting on the PS RAM, or I think that will be the game changer, in my opinion.
Yeah, it'll enable big memory.
Mm-hmm.
Go on, Enrique.
I have something about it. Chip, I need to ask a question because it occurred to me that we can use the DVI streamer setup to do really nice things. If you program the NCO for the streamer with a number like 20 or 30, will it output the same encoding twice or 3 times, or it will try to re-encode the word with another, losing the original word?
I think it. Okay, I
how
think
the streamer works.
I'd have to really look carefully at the code, but I think it's going to run anyway, right? So if you set it for 30 clocks, it would probably repeat the same data 3 times, but it would encode it. It would encode it differently because of the LVDS rules.
You reuse it. You reuse it. No, yes. Not because the LDBS, but LVDS, because the TMDS rules.
TMDS, yeah.
Yes,
TMDS.
because of the running disparity. Okay, it's perfect to me. Chip, we have a winning bit here. Because yes, I need to say that you can use as a small memory as you want. If you put 2 streamers, one over the other, one for the first moment, you can say it is the odd streamer, and the other you can say is an even streamer. And you just enable the two streamers for a cog pair that can share the loot memory. Okay. The first one, we covered it being the even one or the odd one, just generates text or blocks or anything that doesn't need much resolution. The other ever generates the clock, and both are at the same, exactly same frame ever. So when you need to put text, like a scope screen with text at the left side or at the right side, we cover at the top side, you can put the first streamer by yielding twice or three times the bits for each line. So you need, if you put it to duplicate using 20 as the divider, you need also to reinstate the next line, because to turn the pixels square. There is no problem, because normally the information you need to display with text can be useful with few characters or few blocks or few no problem. But at the right side, or the other streamer is ever providing full resolution. And you can switch by only moving the bits at the control port near the cogs. You don't need to upset the pins. You just need to.
Actually, Enrique, I don't know if you looked at Roger's driver. He basically can display horizontal blocks, so he can't split the screen in half. He can just split it horizontal, but he can have a graphic area in the top of the screen, a text area below it, another graphic area below the text area, another text area below the graphic area, and all of them fetch. He has kind of a setup where you basically put a display list. So what lines of the display should fetch from what part of the memory, and if they should interpret it as a bitmap or a text. So basically, all of this is already in his driver, as far as I understand it.
Yes, I understand, but you can do top-down split. But with Roger's driver, you cannot do left side, right side, right side. Yes, but it's just what I'm trying to explain. If you use that technique of putting two streamers, one over the other, into the same pins, just enabling on the fly the one you want controlled by the cog, you can put a picture in picture whichever you want within. Like Peter did something similar when he was Peter he was showing how tacos operates, but there is still a problem with some weird pixels at the beginning and at the leaving of the movie. And also you need to maintain the memory available for full resolution. But if you use that technique for instruments or for panels or for anything you want, you can put like Chip did the Mario characters.
I lost you again. Yeah, but I see what you mean. I guess it's kind of overlaying. Yeah, using two streamers.
Left side of the screen. You can screen with high resolution. Do you copy me? Because I noted my internet connection went bad for some time. Did you copy me?
Yeah.
Okay. Chip, do you agree that is possible?
Well, I don't know. I mean, I got to go and look at the actual code. I'm kind of trying to remember how it works. I'd have to really look at it carefully. It'd probably take me about 15, 20 minutes to kind of study the Verilog and realize how it works. I think it repeats the same data if nothing new comes in, but it might capture it might just grab whatever's there. And if there's nothing there, it might get something unknown. I'm not sure.
If you don't reuse the data register, the longer you capture it from the hub, if you keep it sane between cycles, if it is steady, it only will recode based on the running disparity. I believe you remember I asked you some time back, 2 years ago or something, if we can share the running disparity between cogs. So one cog can know what the other is doing. But then in the last days, I realized that we don't need to share anything because each serial channel is doing its job without problems. So when we change from one resolution to the other, there will be no problem with the running disparity at all. And if we run into any problems, we can pass by a neutral character using into the border, the division between the two screens. You live with a neutral character and start with a neutral character in the next screen. I believe it will work. So for instruments like scopes or wave showers into music, or anything, or picture in picture, or even the most dumb thing, because Raymond did show the board that is able to capture a camera. Okay, you can put two boards capturing cameras and put the two cameras into the same screen without using the full hub for it. You only use the part you need to represent the data you want in such part of the screen that will be high resolution. And the rest of the screen, the markers, everything text or something, even cursors, you can live into the low resolution mode because you switch on the fly and you have ever two cogs able to do the switching. If one is busy doing something, the other one can switch because always done over the enable disable bits of the control ports that are within that cog. So the even cog controls the even part of the screen. The odd cog controls the other odd part of the screen, and they only communicate between their process through interrupt or something to know when to do. And you have CT to perfectly time when to start jumping from one type of screen to the another. You can use the CT to know when you will need to switch from one, because one will be closing his data outputs and the clock never changes. The one that is doing the clock, the 2 bits of clock in high frequency, ever leaves its clock running. Just the other that is using switching between high resolution and lower resolution does, and don't matter if the streamer that is blocked continuous reading characters from the hub, you can stop it, okay? But you don't need to care about it because the data the streamer is outputting is not passing through the control port of the cog of interest. So it's very important to me if you can dedicate at least some minutes to be sure that the streamer will be able to repeat not the data, not the encoding, because the encoding changes on the fly based on the disparity. But if you don't burns the long register, so we don't need to use the literal mode, because having to deal with the mode that enables us to send any type of data is difficult to code. Will burn a lot of time of the code, the code. Please tell me if you understand what I said, because my English is getting worse every day.
Challenging. Your English is challenging.
I don't.
But I think I know what you get. Your thinking is that you have one cog driving a bitmap and the second one using the same pins on the streamer overlaying another display on the same display.
Yes, but just one, just one.
This HDMI stuff, it might work with VGA and TV, but I don't think that HDMI would kind of handle that. What Roger is basically doing is that he is pushing the text display into the graphic area in. I can't really follow his code, but basically he seems to. He can just split vertically, no, horizontally, but not vertically, because he has a line, display line buffer sort of while displaying, and so you can't go in there. His code is extremely complex.
But it's fantastic, because I studied his code many times. And yes, it splits the screen in two, but vertically, not horizontally.
Right.
Because if we could change the frequency of the streamer on the fly, we can try to do it with VGA. But HDMI will not be able to do it because of the change into the clock. The two pins of clock need to run ever and with the same frequency. So let to the PLL at the sync keep synchronized with the 25 megahertz or 30 megahertz.
Roger is setting the clock frequency.
Yes. So keeping the clock frequency steady at the maximum is the better situation. You just need to be able to repeat the data, not exactly repeat because of the recoding needed to compensate for the running disparity, but this is no concern into the sense you can switch between modes by using neutral characters in the border, so they will not upset. And in thesis, you know exact, even if you are putting a pixel over pixel, picture over picture, when you are leaving the text part at the left, you know exactly, you can know if you want, exactly what is the running disparity, because you can calculate it along the line. And you have a lot of time to do it because it can be done before the text is displayed. Another thing, and please put it as a note to yourself in the future when you try to, or you want to put a TMDS receiver into a future version, to let the running disparity as an input, so you can receive it from another chip and put a lot of chips, one in series with the other, and everyone will be able to be worried about what was the running disparity from the last decoder or encoder, and you'll put your new data over the frame and let the next chip knows what is the running disparity you are left in from the output.
Hey, but Henrique, are you thinking though that you can have different streamers running at different frequencies? Because I know that the receiver has a PLL in it that it needs to use to align the bits to the word clock, right?
You can do it with the propeller, but you need a clock recovery outside to be able to synchronize to the other. The German man named Pick something. I don't remember to take a note of his nickname into the forum. He told us something very, very cool. If I need to put a second chip, I don't will put a Intel or Texas Instrument. I will put another propeller. Okay, it's fantastic. Two propellers into board because it wants to put a dual pixel link to his monitor to achieve higher resolution. And it is possible just now, we can do it, but we need to resynchronize one propeller based, or the two propellers at the same time, based into clockings that are upset by a tenth from each other. So not a tenth, but upset by 1 part in 20. So we can synchronize with the falling edge of the first propeller is the rising edge on the next propeller. On the so the it's like having 500 megahertz, for example, and you can put the two propellers running at the same time, one outputting the bits slightly after the other. But you don't need it to do dual pixel. You can output the bolts at the same time using two streamers, but they need to have inverted clock outputs because the chipsets that read in the next stage know what is the even one and what is the odd one. The even one starts the odd one starts by raising the clock, the 25 megahertz, for example, and the even one starts by dropping the clock waveform. So they are complementary. But it's no problem. We can do that. There are chips from Texas that are able to receive two streams of HDMI data or DVI data and output a single stream, doubling the resolution. There are 3 or 4 or 5 from the cost of $3 up to $10 used in automotive market, but some of them are out of stock from the last 3 months about something. So we can do it.
Stuff, yeah. It's kind of irritating. I got
yeah.
I got some chips from DigiKey today. It took 4 or 5 days. Now I can try out that multi-voltage monitoring thing I'm trying to figure out.
Oh, it's a good idea. I was trying to understand what you want exactly. And I saw Bo Schwab and also Philippe Pilgrim. Pilgrim. I don't, I
Yeah,
can't.
yeah, and I'm trying. I got the chips to try to build that what Phil is a kind of was proposing there, because I think it will solve half of my problem, and I can cascade it, so I can without any problem get 64 pins to read instead of 8. I mean, I'm trying with 8, but basically I can cascade it. The problem is that there's no way to put charge current on it. Not like it's just for measurement right now. For charging, I basically need to put FETs on every single cell or pack, which makes things way more expensive and complicated.
The idea of Bo Schwab that using operational amplifiers to output one amplifier for each of the ADCs.
Yeah, yeah, that would solve the problem of having different basically ground references, or no, giving each battery a different ground reference by measuring. That op-amp thing would solve that, but I don't understand them op-amps yet. I looked at the schematic of Bo Schwabe, his name. I couldn't. I'm too stupid. I'm not an E. You know, I'm just a code monkey. I have hard time with kind of.
No, Michael. It's simple. It's simple. Just forget about the analog part. Just look it into as an inverter or not.
Yeah.
You can forget about the analog part. Just look at the relationship for the resistors and the signal of the input. If it's minus or plus, only that. Don't mind about.
I think that is what I like on Phil's solution, because it's simple enough for me to understand. Even if I just use one P1 pin or P2 pin for just one ADC and switch around, but in my opinion, that's something I can understand. That schematic Bo showed me with those, and Frank Friedman also mentioned it. I never worked with op-amps. I mean, I'm stupid, you know. I think that might be the better solution, because if two people tell me about op-amps, I might be running on the wrong path currently. But I will try it out first, you know, and see how it works, and then I can switch to other solutions. I'm more practical, you know. I need to get hands on, and here chips. They arrived today.
The multiplex solution is good because you can use that without thinking about to understand what the amplifier is doing. But I always have a concern to input such a different voltage from one pin to the next until you have 8 cells. So it amounts for 7 times 4 volts, with left to about 29 volts. And the mux are specified to handle up to 20, not more than 20. But Texas has a lot of multiplexes used in cars that are able to withstand with 60 volts. But they are in, yes.
Frank sent me some links to some other chips which are, he also said 60 volts. Yeah, but basically it's currently right just about to try to figure out if the concept itself works. So what I'm just playing around with.
But I believe that Philip and Bo know a lot more about those muxes than I. So I believe, yeah, they knew how they operate internally more very good manner. I don't understand all the implications. So if the differential of the input to the output is not more than 20 volts and not the difference between the input pins. If I study,
that is actually the problem, because I went back to that battery guy I'm working with, and he said they currently run them at 8 volts already. Each cell block is 8 volts. So when I put 8 of them together, I have a difference of kind of 60 volts.
Yes,
but they are not connected at the same time. I'm switching from one pack to the next, so I think it shouldn't matter. Yeah, I will find out the weekend. I build it and I test it out and I see how many of them I burn. I need 2 and I have 12. I need 2, I have 12, so I can destroy some. I mean, in the data sheet, they tell me that it is switching the analog signal without any sink and drain, and doesn't care about the current. I don't believe that one.
How do you know that?
I don't think so. When I push 20 amps in there, it will burn. Yeah, but basically, I'm trying out, but the multiplex, analog multiplex to measure the voltage. I think that part is pretty much nice done with by Phil. I tried that out, but I think it will work. The charging part is different. I have to build something else there. But anyways, I have parts that I can play. My first P2 project, which can really do something. Okay, yeah, Enrique, sorry. We are keeping up here, everybody, I think, and nobody is interested in my multi-voltage monitor thing yet.
Multi-voltage monitor?
Yeah, I try to read basically the voltage of as many cells independent. So I'm basically switching the ground of the propeller from one cell to the next to measure a ground and ADC. I'm switching basically both of them from one battery cell to the next to get it's about battery balancing in serial attached batteries. So I'm like you can do with a multimeter, I just touch the low side and the high side of one battery to measure its voltage and don't care about the whole chain. And now I want to do the P2 to do the same thing that and I'm basically, I have those chips. Phil gave me a link to it. There are analog muxes, so I can kind of fetch. And I'm basically switching ground and I'm basically switching from battery to battery on both ends. So the propeller just sees one battery and they're isolated. A propeller is isolated from the battery.
I wonder if there's some way you could set the pins up in some kind of overlapped arrangement where you can use voltage dividers going to different pins without needing to have any switches, but being able to know what the offset is.
But you need an amplifier because you need to use high valued resistors that will upset the analog to digital converters of the pins. The current you have, the current you have will be upset. And if one cell gets shorted or it gets disconnected, you have a full voltage at one pin. The cells will not act more like Zeners, because when you put several batteries in series, the total voltage tend to be like you have many Zeners in series, H1 able to limit the voltage. And if one cell gets shorted or the connection is lost, instantly you have the maximum voltage at part of the top part and ground at the other part. So you will experience a sudden raise of the voltage in a particular comparator, comparator not, the MUX, exactly the total amount of voltage that is being driven by the charger. So if the charger drives 40 volts or 36, you see 36 volts of the difference in one particular cell just because it was disconnected from the chain.
Right, yeah, and that's the reason why I have 12 of those chips and not 2, because I will burn some of them.
If you see the magic smoke, if you see the magic smoke, you can split. You can split using 4 multiplexers, Michael. You can use, in spite of using 2 multiplex of 8 inputs each one, you can split each part with 2 MUX of 4 inputs. But you need to protect the difference between them with further circuits to ensure that if one cell gets disconnected or shorted, you will, shorted is not a problem, only the limiting current will be reached and the group of cells will not pass too much. But if you have an open cell or an open circuit wire, you will experience the full voltage of the charger into a particular multiplex. And this is the problem.
Yeah, probably, yeah. I will figure out. I mean, I will run it to tests. It's simply enough for me to build on my PDB. I don't have a Johnny Mac yet. I just have a PDB.
Oh, do not use a Johnny Mac.
Check it out. I mean, it's basically independent. I mean, it has an own power supply. It will be opto isolated to the P2. So basically, I think it's a pretty not so dangerous circuit. Phil showed me, and I will try to build that in the next couple of days and find out. I have the parts here. I need some wires and I mean, I have everything here. It's in boxes. I'm building my new man cave, so my old office is sort of in boxes. So I have to go to a lot of boxes to find it.
Please use an older board, not a Johnny Mac. Johnny Mac is a new one and is expensive.
No, I don't have a Johnny Mac yet. I'm waiting for the P2 edges with RAM. Then I will kind of spend half of my money I earn. I'm just waiting. I'm just waiting right now. I need those edges with RAM. Then I will be. I have another project running. I'm decoding now the opcodes of a Cray 1. it's not that much. So I want to build a prey one.
There is a liquid refrigerating made by, it's used in data centers to extinguish fire. The first versions were found to be venomous, but the last one's not. It's named dry water. You just look for dry. I don't know the price of that liquid, but it's a good cooler and is also electrical isolator. So you can dip all your stuff in hardware into an aquarium, fill with that liquid, and push the P2 up to 450 megahertz without concern.
Up to 600.
As long the PLL is able to survive, the P2 will not overheat because the dry water will remove all the heat from the ship.
Yeah, but basically, I'm just playing around with MP2s. I don't have really a valid product in any form or way. It's just that I like those suckers. they make fun, you know. Programming the P2 is fun. It's and the P1. I mean, I do still stuff with P1. No, it's just I don't know why I'm talking about this at all. I mean, it's nobody else is saying anything. Chip, what is about your spin-to-spin compiler? Do you have any time to work on that or don't?
Well, like I said, I want to do something in that area, but I don't know if doing a standard approach is the right way. I feel like I'm waiting for some kind of inspiration that would allow something totally new to be done in the way of tools, and then make them work on the chip, you know, to really tighten the whole loop. But I don't know. I don't know if like 8-bit ASCII is fully the way.
So you are waiting for a muse to kiss you, yeah?
Yeah, and I don't know if it's going to come today or next year or in 5 years.
I will never know. You never know. Okay, so spin to spin is not there. Floating point, you already explained. You are pretty much there. And then there is that other thing I'm complaining in the forum about a lot. And that is your debug screens. You have your debug screens in Peanut and Propeller tool. But basically, in my opinion, you should move all that code to PST. So you have a standalone application which can do terminal screens and graphic screens.
What is?
And then you can serial debug from the P2, from a P1, even from a basic stamp. You can hit that thing with a debug serial debug. I mean, basically it belongs into PST. You need to have a serial terminal input output, and you need your debug screens. And all of this needs to be combined in one application, and you can shoot serial data from any fucking chip you want.
Yeah.
For sure, Peanut and Prop Tool need to support also, but on the end, it comes out as a demo, as a serial stream, and some needs to go to the terminal and some needs to go to them because of those backticks needs to go to them debug screens. In my opinion, all of this belongs into PST, which is currently a pretty, in my opinion, simple terminal program. And if we would add those debug screens there, you wouldn't need to do that in Prop Tool and Peanut, you just add it there. And you even can send data out from a basic stamp to that thing, and it will display nice screens. I mean, it's a serial screen displayer, sort of. I mean, that's a product in itself. You just kind of send the data and it can display screens for it. And I mean, come on, you could send data with a basic stamp. Doesn't matter. It's just the wrong in the wrong environment. It doesn't belong into Peanut. It doesn't belong into Prop Tool. It belongs into PST. And PST is written in Delphi also, so you probably should be able to move that stuff over there, and then maybe, God help, you can use free Pascal and or the newest Delphi common edition, because it's a small program, so it might run with the Delphi common free edition, and you can compile it from Mac and Linux and whatever. And then we have the tool to display the serial terminal and all your DevOps screens, and it, yeah, so constantly hitting the pain button here, but I think that
it's not pain. I'm just so fatigued. My brain is saturated, I think.
Yeah. That would be pretty cool if you could get Lazarus and Free Pascal and recompile that tool.
Right. And I think trying that with Prop Tool and Peanut will not work, because somehow chipset that they're using third-party tools for display a code and stuff. But the terminal program, PST, it's just a simple fucking terminal and those screens. It would be a perfect combination. And that we can run over Lazarus, Free Pascal, maybe, because it's not a large thing. I mean, it's a terminal and those screens. I think that would be a nice, very nice to have that platform independent. You even could send data from Blockly to it and display it on yeah, it doesn't matter. You can use a P1 to send that serial data with ticks for debug statements. I mean, you have to write something. It's not built in like on the P2, but basically you can send it there and it will display it. And you can do it right now with Peanut with kind of some parameter / on it, and then it just displays screens. But having that as a standalone combined with PST would really be, in my opinion, the right decision. And like you said, Free Pascal, Lazarus, or whatever, they should be able, even the Delphi Community Edition, the new one should, I mean, it's a small program, so it shouldn't, I don't know. I don't know much about Pascal. I stopped with modular working with Wills.
Oh, there's not much to know about it. It's just a language.
Well, that Niklas Wirth was a professor in my university in Berlin, in the technical university. I kind of studied under Niklas Wirth, and we had to use modular 2 in that case. It was before I think modular he did before he did. I'm not sure. Yeah, but. Yeah, anyways, in my opinion, you should put all that debug stuff out of Prop Tool and put it into PST, and then we have a separate, and that might be portable to other systems. Short call.
Well, maybe we'll do that. I don't know. I just got to get this floating point stuff working. Then I got to do some stuff for that motor control board.
Yeah, I like that idea too. Man at Work, or I think Man at Work, yeah, he did a board which has things for all 4 coils instead of just 1 shunt for all coils. I'm not sure if it makes a difference. But I'm still thinking about your field control thing and what Anna is saying about the measurement of current. I think maybe 4 shunts would be better than 1, but basically it might not matter. I don't know. It's just my stomach feeling. But else that motor control board you have is pretty interesting, and I hope to can buy some of them soon.
All righty. Well, hey, are you guys getting tired at all? I think my brain filled up a while ago. Yeah.
Can I ask you one more question? I
Of
know you
course.
were tired. Okay. I will try to share my screen. I don't know why. So 1 minute, please. Share screen. Yes. Share where? Share. Okay. Yes. Are you seeing the new PLL match circuit? Match circuit?
Yes.
Okay. You see my cursor?
Yep. Yep.
Okay. In that part, we have the problem with the glitch, okay?
Right.
Exactly here. Oh, thus those NANDs are able to pass the VCO frequency without problem is a question. Can those NANDs or something similar, not exactly a MUX, but a MUX will be used, but can I use 4 or 3 NANDs in series before that point? So the VCO enters the chains of NANDs, but not NANDs exactly. We need to invert the inputs so they become NORs or ORs. It's the same. Because we can inject the VCO through the chain of OR gates or NOR gates, doesn't matter. And that's at the same time, in the other branch of the ORs, we can inject the div signal. And just mute one of them. When we read the count, the CT counter, it's going to be E or D, because the injection will occur when the counter turns to F. So all the 4 least significant bits will be 1. And then we switch the VCO signal into the middle, not in the first, not into the last. Anyone from the middle, we don't need 4, we can use 3. Anyone from the middle will receive the VCO signal. So the other branch of the ORs will keep the output 1 for just some more clocks. And when we cut the DV signal, it will just be the VCO changing. There will be no glitch because it's like using wired OR configurations. So if one of them is 1, doesn't matter if the other is clocking to 0 at higher frequency. If this one is high during the whole change cycle, we don't have the problem of this one switching and faster, because that one will control the output. So it's not important that we lose some cycles. The only consequence is we will have not exactly know how much time the CT will be counting during those 3 or 4 cycles. Is that possible or not? Use a chain of ORs like a shift register, but that have OR input, so we can ensure that one branch of the ORs is controlling the whole output during the transition time.
Well, okay, are you thinking about, I mean, this all happens inside the chip. This is all hardwired silicon, and that P0 to
Yes,
P3,
yes, I
those
know,
are
I know.
those are the values that come from the divider, or no, from the post divider.
Yes, the post divider, yes.
So the only way you can modify those bits is to do a hub set instruction.
No, you need to do a hub set instruction to change from the div to the VCO and vice versa. And we cannot do this now on the fly because we have a glitch in that circuit. That glitch impedes us from doing, blocks us from doing the on-the-fly change between those two. We cannot do that. But if you have a chain of muxes, muxes not, a chain of ORs receiving in one part of the ORs, the VCO signal, in the other can be three input ORs, meaning not 2 input ORs, can be 3 input ORs. One input is from the earlier stage, other input is the VCO, and the third input is div. And I block the VCO or enable it only when I know, reading the CT, that the counter, the divider counter will maintain its output as 1 for more than 2 or 3 cycles of the VCO. So what happens with the waveform is the VCO will enter in the middle of the waveform. But since the other side is always 1 during the cycle, for as long as 3 or 4 clock cycles, we are not upsetting the output. The output will be kept constant as 1. And at the moment we close the mux that enables the passing of div, the VCO will be controlling, but you have a same transition from 0 to 1 or from 1 to 0, in fact.
I don't fully understand what you're saying. I know what you want to do is time the transition so it's not going to create a glitch, right?
Yes, the transition only occurs when you read the CT counter and the last 4 bits or 3 bits are going to be 1.
Well, here's the thing. You don't know when the clock was changed. So you don't know, there's probably no certain relationship.
No, you know when the clock changes because the instructions are clocked by the raising border of the clock.
Okay, so what you would do is you would grab the counter then and look at it. But the counter's granularity is a whole clock cycle.
Yes, right? Yes. Just is why I'm suggesting you to inject the pulse into the middle of the group of chained NOR gates, so you can ensure that even if the clock goes at higher speed, the next bits of the counter will reflect those, no, not those, but the last divisions of the div. So you can be ensured that the div will keep high until the counter ticks down to 0 again. Imagine imagine the CT is a decreasing counter, not increasing. So you are just looking for 0. When you look for 0, you know that by the next 3 or 4 clocks, some bit of the div output will be high. And if you inject that bit into the ORs, that bit will be kept high until it is clocked by the new clock. It's being clocked by the old one, but when you inject the div bit, the bit 3 or bit 2 of the div of the CT or for the div 2, they are the same. In essence, they are the same. When you inject one higher bit of the counter into the chain of ORs, the chain of ORs will act just like a shift register in my mind, or just part of a ring oscillator. Imagine you can put one into a branch of a ring oscillator and set all the outputs to 1 and inject the faster clock into the middle. So while the ring oscillator is shifting out, if you don't cut the slowest one, it will be kept shifting only the slowest frequency. But when you cut the slowest frequencies, the slower frequency, the higher frequency will be right driving in the right place. So it will last 1 or 3 or 2 clock ticks until the ring exhausts and presents in its output the VCO signal.
Well, I don't know if that would work. I mean, the VCO is always going to be running faster than the div, right?
Well, it's just, yes, VCO is always running faster. But when you are using mux, the clock of the mux is dependent of that logic that takes a while to change. So the whole time that leaves for that control signals to get there, it's supposed for the VCO signal to bring down and upset the output of the div that perhaps is going up at the same time. So you have a glitch at output. But if you can ensure that not using exactly that mux, but if you can ensure that you are injecting the faster clock VCO into the middle of a string of high bits, you are sure you are not upsetting nothing, because any glitch will be masked by the other branch of the ORs. It will be kept there until the div signal falls to 0. And then when the div signal falls to 0, that mux can be closed. Because at the same time, when the div signal falls to 0, the VCO has already go up. Because it's that signal that increases the counter.
Yeah, I don't know if it's possible to do that, because I'm not sure. I'd have to look at the schematic and try to figure out the likely relationship between VCO and div. And if there's anything that can be known for sure about the phases of the two, I don't know.
VCO is used to clock the div.
Right.
We know. So that signal changes after VCO goes up. Or it's not the PLL that clocks div, it's the VCO that clocks div. So the PLL is a result not a generator. The VCO is the generator. And just after VCO raises, some phantom, some picoseconds, or even 1 nanosecond after, div is stable.
Yeah, it could
So
be.
if you, and div will almost match the last bits of div will almost match the bits of the CT counter, because both are clocked. But one of them is clocked by the VCR, but the other is clocked by that signal. So while you are clocking at slower frequency, the output of CT will be toggling at slower frequency. Only when we switch between one and the other is that the moment that the div will be the exactly match the, no, they will differ. They will differ when you clock the next pulse, because then div will be running faster during some time, then it will be the same as the counter again. It's
Right.
something I cannot explain totally, but I believe you got the idea. Is having ensured that the div signal will remain high during all the VCO changes. So we can inject the faster one into the ores in the middle, and when we exhaust the other, the one that rests is the VCO. So the PLL will not have the glitch because the div will cover the shorter pulses.
Yeah, I don't know. I'd have to really look at the rest of the schematic and try to reason it out and then run some tests. I am just not really sure.
Okay, it occurred to me that this is a possible way to fix in the future when you need to redesign part of the the pad ring because of the needed changes in the future. You can look at that, at this.
Yes.
Okay, thank you, thank you. Excuse me for the long time.
That's okay, Enrique. So, yeah, I don't know. I've thought about what needs to be done to just fix this in hardware, but I don't know how, we'd have to sell a lot more chips, and On Semi would have to be interested in, more, letting us pay them some more NRE, and then coming up with a new, any change in them, any change to our chip results in what they term a program change. And that has all these knock-on effects of things getting reset, and their accounting department doesn't like it. And so they want to see like a lot of device sales for the current part number that we have. And just getting that via removed to stop the crosstalk between the adjacent A to D pins, that was a huge struggle to get through. But there's a lot of stuff I'd like to tune up if we have the opportunity, and maybe we'll get the opportunity in the future.
Okay, okay, I got it.
Yeah, all right. Okay,
Thanks, thanks for your time.
Well, thanks for your pointing these things out, Enrique. Is there anything else anyone else would like to talk about before we go? All right. Okay, I got to get ready. I got to go down to San Francisco tomorrow morning to pick up my cousin who's moving up here to Red Bluff. And we're going to empty out his apartment down there, hopefully. It's a hard thing for him to do because he's got all this nostalgic connection to this place, but he needs to get out of there. So we're gonna move him tomorrow. I gotta get the truck ready to go and everything. So thanks for coming today, you guys, and all of your input. And hopefully we'll see you next week or the week after.
Thanks for your patience.
Yeah, and thanks for all your input. Okay, so I'll end this now and we'll look forward to seeing you all later. Okay, bye-bye.
Bye.
Bye-bye.